Welcome to EDU World Space.
Okay, so we have like the picture, an astronaut. It's standing in the North Pole of a newly discovered, perfectly spherically, just like the drawing, planet. And this planet has a radius r. Okay, so he's holding some liquid. Okay, we know the mass, we know the volume, and we know, like the second drawing here, that at the surface of the liquid, the pressure is P0. And when we go a depth D below the surface, we have another pressure that it's actually P greater than P0. Okay. And we want to determine the mass of the planet using this. So it's kind of easy if you remember that G, or the value of the acceleration of the planet. This is the uh, well, it's equal to g, that is the universal constant, times the mass of the planet, okay, divided by the radius of the planet squared. Okay, so this is the g we know as 9.81 in Earth, but in another planet has a different value. Okay, but you see it depends on the mass and on the radius of the planet. Okay, and we know also that the pressure in a fluid of uniform density, okay, is the initial pressure, okay, times the density times G times D, okay. So you see, actually, this is like the initial pressure. This is like the pressure the atmosphere does in the liquid. And this is a pressure that depends on D, the distance you go below the surface, okay, because it's like you're carrying all the liquid that is above. Okay, so this is through the liquid, this is for the planet, okay? And then we find that P minus P0, okay, well, I'm just rearranging, equals the density times G times D. Okay, so then we have that this is our second equation. And what we have to do now, okay, is substitute 2 into 1 and solve in the terms of the data we know. Okay, so when we do this, we find that P minus P0 equals, I'm going to substitute this G, okay, for the value in 1. So this is the density times the constant times the mass divided by r squared times the distance d. Okay, and I want to find the mass of the planet. Okay, so I have to rearrange. Okay, and I find that m equals p minus p0 times r squared, the radius squared, times density constant and d. Okay, we do not know the density, but we know that density equals volume. No, sorry, it's the other way. It's mass divided by volume. Okay, so when I substitute this in this part, I find then that the mass of the planet is p minus p squared. No, not squared, just p minus p0. Sorry, times v times r squared divided by the mass, the constant, and distance.